U is a representation of the group. U is immediately representation of the group, and pi is a homomorphism from A to BH. It is a representation of the system algebra such that pi is the identity, tau A is Q, pi A is the identity U star. So such a thing is called a covariant representation, and as you can imagine, if A zeta is algorithm, then there exists a unique covariant representation of this system in H row. H row is L2 of A with respect to this H row. So if that is there, then there is a unique covariant representation, and so now we can make our definition. Namely, I define spectral dimension of this quantity is really infimum of alpha such that, oh sorry, I need one more concept. I am sorry, I need one more concept. So A spectral triple A H row D. Remember that as soon as I have fixed row, I have got the genus representation. So this representation is fixed. Is called equivariant if so I have this so if D tensor identity commutes with U, then you call it equivariant, and now I can define whatever I wish to define. Infimum of alpha such that A H row D is an equivariant spectral group trace mod B power minus alpha is finite. This is really tractable for really very simple reasons. We will see in a moment why this quantity is tractable. So it is this quantity which we want to call this, and of course if A itself is a compact quantum group, so therefore we can define every group is an instance of such a quantity, so I can define this quantity. This is quite a simple definition, and so I do not wish to hurry, therefore I first discuss the simple open question which we cannot answer, meaning do not know, it could be done. I do not think this question is very difficult, but then one can ask difficult questions also. Or maybe before that at least I want to. There are many variations of this theme is possible, therefore I just discussed the first variation. Because KBS was asking whether all these numbers, so let us try to compute this for Lie groups and so on, whether in those cases these numbers give something known or unknown. Do you encounter some sort of a surprise? KBS was asking for that. So there is one simple variation which does that. Yeah, so I am just interested in computing the dimension of a Lie group say itself. So group acting on itself. So, but I will define the variation even in this case. So we do not have any notation for these variations in our paper because we do not discuss these variations. It is just a passing remark that one can consider. Therefore, there is no fixed notion. Variation is absolutely simple, but you may ask why this variation, that I will explain in a moment. So I look at equivariant spectral table. I put one more condition. Sign D, remember that starting with the spectral table it determines the freedom module. Therefore, starting with D I determine this, and I said this is not a compact perturbation of identity. I made this simple condition. These are the meaning which I will tell in a moment. And then I look at these quantities. So maybe I call it spectral dimension prime of A, G, tau. If you compute this quantity for whatever definition which I gave, if you compute it for SU2, I will do the SU2 computation in a moment, that will give you 3. If you compute it for it is 4. If I compute this quantity for SU2, it is 4.
For any or equivariant.
Equivariant. Of course, otherwise it will be complicated to compute.
Why do you put this condition? Is it always so or is it?
Yes. Which is always so?
Kindly, it looks like it will never be compact.
No, it can be. Yes, of course, I will do that in a moment. It is precisely in this Laplacian kind of situation. It is identity. Sign of Laplacian is identity.
D is a first order operator.
So you take square root.
Yes, still true.
So it is still true.
No, you have a negative spectrum.
No.
Yes, square root. We take a positive square root only.
Meaning otherwise, how do you define square root? You have to choose a sign.
If you take the Clifford element, then you will have a negative square. That is the problem.
Now again let me repeat. So it is this condition which makes it non-trivial. I cannot say it makes it non-trivial, but if it is not so, if I drop this condition, that means allow these things to be identity, then in many instances it will become trivial, exactly homology class, but trivial.
Not identity, but what you say, compact, not a compact perturbation.
Compact perturbation of identity and identity are more or less same. And in this case it is more or less same, meaning it is not what I mean. That's why you remember while defining sign of D for circle, I said I do not mind how to define it for 0. All that matters is any outside a compact set, what are these values?
So can you find an example where it is not a
Yeah, I do that in a
But
moment.
it is a compact perturbation of identity.
It is identity.
No, its identity is a trivial case. But
If I can do it,
non-trivial
yes, I mentioned if I can manage it for its identity, I can manage it for compact perturbation of identity. So I
I'm talking
will
about classical control. Okay. Take a classical space where we take the Laplacian or the Dirac operation.
That's what I'm saying. It will not matter. That's what I'm saying. So please, I'll give an example. I'll give an yes.
What is the spectral dimension of SU2?
3.
As expected.
Yes. Yes.
Is the correct
We strongly believe that it is dimension
in all classical cases.
Lie groups. For compact Lie groups, it will be so.
And it's known for some.
We can extend our arguments for SUN, and I believe we can extend it through it in a case-by-case basis, which I do not like.
Well, but what about SU3?
It is dimension of SUN. That is precisely the main result, which I will not discuss.
Okay.
Yeah, that is really complicated.
Q independent.
Q independence. That is a slightly complicated argument, so it I will not do. But since there are some research scholars and I promised some simple tractable problem, therefore I should explain that problem in detail.
And I suppose you get funny answers for this modified.
Huh?
I suppose you get funny answers for this modified one when you put Q and N in.
Yeah, in this case we do not know really, meaning you have no guess what this number is. So, meaning particularly for outstation candidates who are not from institutes like ISI. So, I want to define this concept somewhat carefully in the simple case of spheres. So, Sn, so I take my A to be continuous functions on the n-dimensional sphere. I know that the orthogonal group On acts on this object. It is a compact group. So this is a compact group G, and I know that G acts on this space Sn. How do I describe the invariant measure of Sn? So let f